Good morning, Algebra 2. Good to see you. We're going to try and make this a quick video. 4.4, we are factoring some polynomials. We're going to use this to help us simplify some expressions, and we will get to division in second semester. That will be our first lesson in second semester. Learning target today. I can use factoring to write a polynomial as the product of other polynomials of lesser degree. Again, just recognizing that we're going to use factoring to kind of break them up into smaller polynomials. Success criteria, we're going to look at some special factoring patterns. They have nice names, and we're also going to look at factor by grouping. Pause if you need to. Okay, make yourself a little note. Always factor out what I call the GCF, the greatest common factor. Before you even start, just run through your polynomial. Can you factor anything out? These may be some examples that you want to get down. Hey, check it out. If you look at these two terms, the greatest common factor, they both have a factor of 10. Here's a 10 here. I know that 40 is 10 times 4, right? So you could factor out a 10. This should be pretty much review from a long time ago. There we go, right? Between these two terms, if I wanted to factor out the greatest common factor, well, I know they both have a factor of 4, and they both have a factor of x, right? X is being multiplied to both of these terms. Factor out a 4x. What are you left with? Well, the 4 is gone, right? One of my x's is gone. It got factored out, but I'm still left with just one x there. Here, if I factor out a 4, well, 12 divided by 4 is 3, and I take out an x, that's gone too. You're just left with 3, right? Here on this one, I can factor out a 2, and I can also take out an x from both of these. So I can factor out a 2x. What's left in my expression? If I take 2x away from 2x, well, 2x divided by 2x is just 1, right? So you're left with 1 plus, again, pull a 2x out of here, you're just left with 3x squared, right? Because I already pulled 1 out of there. You got to lower the exponent to x squared. Pause if you want to get maybe 1 or 2 examples down. Okay, before we start into the special factoring patterns, I do want you to recall this from Algebra 1. This should be familiar. If it's not, let me know. We can talk about it more. If you were given something like this, you would factor it out to be here, right? As 2 linear factors. What are 2 numbers that multiply to be -3 but add to be a +2? You would factor this out to x minus 1 multiplied by x plus 3, all right? Same thing with this guy here. Again, this should be review. If it's not, let me know. What are 2 numbers that multiply to be a -15 but add to be a -2? Well, I know that 3 times a -5 is -15, and they both add to be -2, right? And if you want to confirm that these two are the same, or that these two are the same expressions, just take this thing and multiply it. We did multiplication in our last section. Foil that guy all out, and you're going to get this here, all right? So just a little review. I don't know if you want to get any of those examples down. Pause if you need to. All right, our first special factoring pattern is if we wanted to factor perfect square trinomials. You may want to pause and get this down. This right there is a perfect square. And if you multiplied, right, if you multiplied a plus b times another a plus b, you would get this here. Or if you multiplied a minus b multiplied by another a minus b, you would get this, all right? And we can use this to help us simplify some, or factor some expressions. So I have those rules up here. You don't need to write those down. Maybe a good idea to get some of these examples here. So let's look at this. Let's see if this is a perfect square trinomial. Notice how at the end of all these, we've got like a b squared, and then we have 2 times a times b. So I know that 1 squared is 1, and 1 times 2, and you know, you'll get more practice recognizing these. They'll become quicker. 2 times 1 is just 2, right? And notice how we're subtracting. So that would fall underneath this one here, where I have x squared minus 2 times 1 times x, that's that part right there, plus 1 squared, right? So now I can see that it's going to factor out to be something like this, where we have a minus b squared. In this case, your a is that first term, the x, right? That's being squared. Your b right here is the 1 squared. So this can just factor to x minus 1, kind of following that pattern right there, x minus 1 squared. And you may be able to just look at that, and say, hey, what are two numbers that multiply to be 1 but add to be a negative 2? You could probably factor it like that. The b's will start going quicker. Hey, 49, I know that's a square number. You could write that as 7 squared, right? And I also know that 2 times 7 is 14. So you should be able to write this as one of these perfect squares. I'm going to get rid of that here. So if 49 is 7 squared and 14 is 2 times 7, and hey, it's a plus, it's a positive, right? Kind of like this guy here. Well, kind of our key word or our magic number here is going to be the 7, right? So it would be x plus 7 squared. Again, let's look at this one here. 16, that's a square number. That's 4 squared. I also know that 2 times 4 is 8. So yeah, this looks like it's going to fall underneath one of these patterns. So x, it's going to be a plus 4. Notice again, there's the difference between these two that you just wrote down. So x plus 4 squared. Here, 9 is 3 squared. And 3 times 2 is 6, right? And there's a negative 6, so I know that this is going to be x minus 3 squared, all right? So that is the perfect square trinomials factoring pattern. Pause if you want to get maybe an example or two down. Let's now look at difference of squares. This one's pretty easy. I like this one. So if you can recognize a polynomial that's in the form of a square number subtracted by a square number, then it's going to simplify out to be this, where we have the first thing added to the second thing, multiplied by the first thing, subtract the second thing. Pause to get that down. Let's look at some examples. These are really easy, I like these. So, x squared minus 25. Hey, 25 is a square number. X squared, it's literally something being squared, right? So that's also a square number. You could write this as x squared minus 5 squared. And now we see those two things that are being squared, the x and the 5, right? And then you can just write it in this form. This simplifies to x plus 5 multiplied by x minus 5. And again, if you FOILed that all out, you'll get that. You can check me if you want. Over here, I know 16 is a square number. X squared is obviously, it's a square, right? So you could write this as x squared minus 4 squared. There's our two numbers. Boom, boom. This factors out to be x plus 4 multiplied by x minus 4. There's our difference of squares. Okay, this one here, 100 is a square number, 9 is a square number. You could subtract it, you'll get 91, right? But again, we're just recognizing that these are square numbers. I could write this as 10 squared minus 3 squared. If you wanted to factor that out, and again, this is kind of unnecessary since we have those numbers, we could just subtract, but well, if you wanted to factor that out, that's going to be 10 plus 3 multiplied by 10 minus 3. And then we could simplify again. 10 plus 3 is 13. 10 minus 3 is 7. Is 13 times 7 equal to 91? Yes, it is. Last one here. We have 4x squared minus 81. This one's a little tricky. Now we have 4 being multiplied to x squared. X squared is a square. Is 4 a perfect square? Yes, it is, because it's 2 squared, right? So, kind of like what we did here with these first steps, you could write this as 2x squared. absorb that and make sure that makes sense. Minus 9 squared. All right, so 2x squared is the same thing as 4x squared. 4 times x squared, right? And then you could, again, factor using that little pattern. So it's going to be 2x minus 9 multiplied by 2x plus 9. There we go. Pause if you need to get any of those examples down, maybe 1 or 2. Okay, here we have difference of cubes. This one's kind of crazy, so definitely write this down. If you want some of these little helpful hints, you can as well, but again, let's get that difference of cubes. Pause if you want to get that down. Remember, difference of cubes. Cubes is something that is raised to the 3rd power, and here we see that we have a cube number, a cubed, is being subtracted, b cubed, right? So difference, subtraction, there we go, right? You notice that, you say, hey, I can use one of those special factoring patterns. Let's look at some examples. So, again, that's just the pattern there. We've got x cubed minus 27. Now, 27 is a cube number. It's actually 3 times 3 times 3. So it's 3 cubed. So I'm going to write this a little bit differently. I'm going to say, okay, this is x cubed minus 3 cubed. All right, now I have difference of cubes. I know I'm cubing x, I'm cubing 3. So now we can just kind of follow this thing here, right? This says, we'll take those numbers that are being cubed and subtract them. So this is going to factor out to be x minus 3 multiplied by a second polynomial. Here we have a squared. So that was the first term, in this case, x. So I'm going to take x, I'm going to square it, plus a times b. Again, those were the things that were being cubed and subtracted. So it's x times 3, right? So plus 3x. And then plus b squared. That was the last thing that was being cubed. So I'm going to take 3, I'm going to square it, I'm going to get 9, so I'm just going to add 9 onto the end. All right, so that first example factors out to be this here. And then we could further go and say, all right, can we factor this second one a little further? Right now we can't. You could use the quadratic formula if you want, but there's no 2 numbers that multiply to be 9. There's no nice numbers. There's no nice numbers that multiply to be 9 but add to be positive 3 there. All right, so we're just going to leave that here in that form, difference of cubes. Let's look at a couple more here. This one, I recognize that this could be written as x cubed minus 4 cubed. All right, and hey, let's just take this, follow our example. So that's going to be, it's going to factor out to be x minus 4 multiplied by, again, a giant second polynomial where we have the first thing squared, so x squared plus the 2 things multiplied together, right? So we got x and we got 4, so plus 4x. And then that last thing, which in this case is our 4, the last thing that's being cubed. 4, we're going to square it and add it to the end. 4 squared is 16, all right? Pause. I think I'm going to save time. We're going to talk about these ones later. Pause, get some examples down. Last one, we'll talk about factoring by grouping. Now, this looks like a lot, all right? Pause, get it down. Let's break it down real quick. Okay, when you factor by grouping, you may need to rearrange some terms, see what you have in common. We'll just kind of break down this example, then we'll see one with actual numbers and variables, all right? So again, these are just parameters. We have r times a plus r times b. Here, in these first 2 terms, the thing that I have in common is an r. And then we have plus sa plus sb. Here, in these last two terms, the thing that I have in common is an s, right? That greatest common factor. So really, we're just factoring out the greatest common factor and then seeing where we can go with it. So if you factored out an r from here and an s from these last two terms, you would have r times a plus b plus s times a plus b. Okay, and now if we look at just this part here, we say, hey, I've got an a plus b and an a plus b being multiplied to the r and the s, right? You could factor out a common factor of a plus b, since again, it's both right here and right here. So if you factor out a plus b, well, now you're just left with r plus s, and then you had already factored out the a plus the b. This is kind of crazy. We'll see an example here in just a second. Pause if you need to again. All right. So again, I have that huge rule that you can reference. Let's look at this. We're going to factor by grouping. Let's look at the first two terms. Do I have something in common? I have an x and I have an x in both terms, right? So it looks like I can factor out an x. I don't need to rearrange any terms right now. It looks like we're good. What about these two terms? Do I have something in common? Yeah, I've got a 3, and I could pull out a 3 from here, right? 12 divided by 3 is 4. So from these first two terms, let's pull out an x, and from these two terms, let's factor out a 3. So I'm going to kind of try and color code this here a little bit. If I factor out an x, it's just going to be x times y plus 4. And here, these last two terms that we're grouping together, we said we could factor out a 3. So I'm going to factor out a positive 3. What's left? Y plus 4 is left there. Okay, now we'll pause, and say, hey, is there anything else that I could do? Yes. When we factored out the x and the 3, check it out. We were left with a y plus 4 and a y plus 4. We could continue to factor that out, right? I mean, that's just a product. I mean, it's two things being added together, but that product is being, or that sum is being multiplied to the x and the 3, so just factor that thing out. So if I factor out a y plus 4, well, all that's going to be left is the x. Over here, all that's going to be left is the plus 3. There we go. Fully factored into two separate terms there. Pause if you want to get that example down. And I would like to see you in Blackman 107 tomorrow. Okay? So tomorrow, show me your notes and we'll go over a review and talk about all of these factoring things, because I'm sure you have some more questions / want some more examples. Bye! Can't end a class like that. Bye!